Hi, let's talk about absolute value stuff. What does an absolute value do to a number again? Well, it makes it positive if it's negative, and it does absolutely nothing if it's already positive. Okay, well, zero isn't really positive or negative, but it's still zero. I'll give you that. One is positive, 2 is positive, 3 is positive, 4 is positive, 5 is positive. Whoa, it's kind of just like linear right there. Boopity boop. And then what about negative numbers? Well, negative x values have to give us positive y values because it's absolute value. So negative 1, positive 1, negative 2, positive 2, negative 3, positive 3, negative 4, positive 4, negative 5, and positive 5. That also looks kind of linear. Hey, look, it's almost as if it was just a y equals x linear graph that's been flooped up to be only positive. Almost like that, right? Weird. You know what's crazy? It's also almost like you kind of squared a number and then square rooted it, right? Think about like negative 4. If you squared negative 4, you'd get 16. If you then square rooted it, you'd get positive 4. Weird. Well, that's something to think about anyways. But there you have it. Let's talk about the D and R. The domain of this function is all real numbers. You can plop any real number in and take its absolute value. Ain't no biggie there. So we are talking negative infinity to positive infinity. Scooby-Dee, x is an element of that interval. And for our range, we can only be positive numbers. So we can only use the real numbers that are greater than or equal to 0. So in interval notation, y is an element of the interval 0 inclusive, which is why I'm using a bracket, comma, infinity exclusive, because you cannot grasp the concept of infinity. Well, that's pretty much that. Pretty straightforward, except for that weird square root of x squared thing. I don't know what's going on there. But let's talk about abs x over x. Well, this is kind of weird. But again, think about what's going on here. If x is already a positive number, well, absolute value of x is not doing anything. Well, so let's maybe think of this as like a piecewise function. Let's say that if x is greater than 0, then really we're just dealing with x over x. Because x is already positive, so the absolute value is not doing anything. But x over x is kind of silly, because we know that when a fraction has the same numerator and denominator, it's just 1. And if we think about the x values where x is less than 0, well, think about what's going to happen. The numerator, if we have a negative x value, is going to become positive. So if our x value is negative when x is less than 0, the numerator is actually going to become the opposite of x. The denominator is going to become still just x, which is a negative number. I know it looks weird with that negative in front of the x, but I'm hoping you can follow that argument. But again, we have this x over x, which we know is just 1. So really, that's just negative 1. Well, what about at the x value of 0? Well, at the x value of 0, we would get 0 over 0, which is undefined. It's an indeterminate form. It is a whole, if you remember the rational functions unit. So if I'm greater than 1, I'm at positive 1. If I'm greater than 0, my x values, my y value is just positive 1. If I'm less than 0, my y value is just negative 1. And I have a whole at the x value of 0, which is why I have those circles on my graph. And that's pretty much it. Well, I want to point out a couple key things about this graph. I want you to kind of picture an axis running between the middle of these two branches. Because notice we can find a middle point, and normally that middle point is just at the y value of 0. Now, that's going to help us when we do our transformations. The other thing that's going to help us when we do our transformations is to recognize that the top branch is 1 up from the middle point. The bottom branch is 1 down from the middle point. That's going to help us later on. And also recognize that to the right, we are up, and to the left we're down, and that's coming from that positive negative bit. All that's going to stay true as we start applying transformations unless we have some sort of reflections in there. So, domain and range. Well, domain, I am going to say x is an element of the set of all real numbers such that x is not equal to 0, because it cannot equal 0 there. In interval notation, x is an element of the interval negative infinity up to but not including 0, union with the set 0, non-inclusive, up to infinity. That is how you write that, excluding 0. Now, for the range, it's a little different. I'm not going to use interval notation for this. It wouldn't make sense because there are only two y values that I can possibly be. Y can only be -1 or +1. Now, that's weird. Doesn't that say everything between -1 and +1? No, it does not, because I used curly braces. That is set notation. I am saying, hey, look, y can be these two specific numbers.